Hello and welcome. This is the first episode of AI Workflows with LangGraph, where we implement AI automations based on patterns proposed by Anthropic in their blog post called Building Effective Agents. Okay, so the first workflow pattern we're going to implement is prompt chaining. This one is easy to understand. It's quite easy to implement, but it's still really powerful, and you will get really accurate and high quality results with it. At the same time, it's really important to understand it because it's the backbone of the other patterns we're going to implement in this series. So you take the process, best if it's a linear process, you divide it into number of steps and basically make LLM execute those steps in predefined order, and at the end you get your final results. And this high quality results comes from the fact that LLM performs really great if you give it a simple to accomplish task. So the easiest to accomplish steps, the better in this pattern. But there's a trade-off here. So we get really great results, but the price to pay here for these results is basically the time, because we have to wait for each step to execute before you proceed to another one. So the timeline is quite long. Okay guys, so before we move to the code, let's cover some basics of LangGraph. And LangGraph is your low-level orchestration framework to build LLM-powered applications. And you do it by defining your AI agents or AI workflows as graphs. And for today's patterns, all you need to understand are the main three components. And the most important one is state, which basically is data structure that represent snapshot of your graph at any given time. Nodes, which is the second component, are Python function that encode some logic such as call LLM to do some stuff for you. And those function as input takes the graph state, and they has to return the partial state that will update the overall state of the graph. And edges, which are the third component, defines how those nodes are connected and basically determine which node will be executed after the current one. And if you combine all these three things, you get the LangGraph application that can do all the magical stuff for you. Okay guys, so it's time to build something. And what we're going to implement is AI automations that will create product descriptions for some e-commerce shop, for example, based on product image and some specifications. So what you see on the screen is the final graph, which as an input will take the product ID, and then we'll find product details in mocked database. If we find product, we'll go right and create all these nice things. But if there is no product, we need to stop our execution and basically end the chain. Okay, so you can get the code from the GitHub repository. There is the link in the description. So each episode is going to have the separate folder, and the first one is prompt chaining. As mentioned, we've got three main components to take care of. First one is state, and the state is basically typedict, which is the schema that will evolve with execution of each node in our graph. As input, we want to take product ID, then we've got some attributes for the response from mock database, and we've got our expected outputs. So basically the product features from image, product description, product short description, SEO title, SEO description, and keywords. Okay, so let's move to nodes. Nodes are, as mentioned, Python function, which takes state as input, performs some logic like retrieval, inference with LLM, and so on, and return value that we want to update our state with. And this return value has to be our state partial. And for the first node, we've got find product details, where we are looking for a product with given ID in our mock database, which is stored in mock data.json. If we find some such product, we return the partial with the information from our database. If not, we return the empty object, well, dictionary. Then we've got the next node, which is extract product features from image. And as you can see, we're using GPT-4o Mini and ask it to analyze the product image and extract key visuals, and we provide the URL to the product. And we return the response from the model as the product features from image. For the next node, it's similar to the previous one. So we ask GPT model to basically create product description. We provide some requirements and the overall task, and the information we've got from the database, and also our visual features from the previous node. And the next nodes are very similar. So we got generated product short description where we provide the product description, and we've got some requirements, and basically create a concise product summary for use in listings, search results, and catalog entries. There's another one with SEO title and another one with SEO description. And at the end, we are asking for the product keywords, and all of these nodes perform really similar logic. What the difference between them basically lies in the prompt. Okay, so it's time to define the order in which the nodes are going to be executed. But before we do it, we need to initialize our graph. So we basically initialize our graph this way. So graph equals state graph, where we provide our state schema. We need to initialize our nodes. So we use the graph state graph function named add node, where we provide basically the name for the node and the function that is going to be executed in this node. And here's where we define the workflow by connecting the nodes. And as you can see, it's really simple. You just use the add edge function, where you specify the nodes that needs to be connected by the edge. But there's also this graph.add conditional edges, which is basically your if-else statement in graph. And we'll use it to make sure that the graph is going to be stopped if there is no such product in our database. And to do it, we need a function called getProductFound, which is implemented here. And as you can see, this function takes state as input, but it returns the name of the names of edges that the flow should be executed next. So if there is no product name in our state, we want to go to the end. But if there is, we want just to move forward and analyze product image. And as you can see, we can basically connect with these strings with proper nodes names here. And finally, we need to basically compile our graph to workflow this way. Okay, guys, that's it. We should have working solution now. So we defined the state schema. We implemented nodes, also connected them with edges, and we put some conditional edges to make sure we are not going to proceed with our workflow if there is no such product in our database. So now it's time to check it in action. So you can open your terminal, typed LangGraph dev, and you will see the LangGraph Studio, which is basically a really great tool from the LangChain that helps you debug and monitor and basically evaluate what's going on in your graph. So let's provide the value for the product ID. And what we will see when I click submit, that on the left side we'll see the visualization of what is happening in the graph. And on the right side we'll see the value that is that we'll have from each node basically. So when we click submit here, we see that we find the product details. Now we extracting product features from image. We've got the generating product description, and we move to another nodes basically. So let's evaluate what is on the right side. So we started with the start node where we provided product ID. Then we found some information on our product, which is basically the Sony headphones with such image. The next node was this one, so extract product features from image, and this is what the GPT figure out based on the image. And we proceed with simple LLM inference when we ask to make the product description, short description, SEO title, SEO description, and the keywords. So as you can see, it works, and you could use the output value and basically send it to some external system to update the database with the prepared information. Thanks for watching till the end. It means a lot to me. If you like the video, please subscribe. And in the next one, we are going to implement the pattern that will optimize the execution time of today's pattern. So until the next time, cheers.